In our first example, we are looking at a first order reaction. We are given a reaction and we are told that it is first order. It's first order in respect to A, and then we are given the information about the rate constant. So this is K at a certain temperature. Remember, temperature is represented by a capital T. This is just extra information that's important to the problem, but not important to the math. How long is represented by a lowercase t for time. How long will it take for A to decrease from 0.88 to 0.14? So 0.88 is our initial concentration. And at time t, the time that we're solving for, the concentration is equal to 0.14. All right, so for first order, we go look at our list of equations and we pull the first order integrated rate equation, and this is what we have. If the reaction were second or zero, we would just pull that corresponding equation. And then we plug in the information that we know and solve for what's missing. So in this case, we have the natural log of A, so 0.14, is equal to the natural log of A0, so the initial concentration. It's important not to mix up these two different A's, minus 2.8 times 10 to the negative 2 times T. All right, one thing to notice is that this K is in seconds. So when I solve, my time is going to be in seconds. If my K were given in years, when I solve for time, my time would be in years. So just pay attention to the units you're working in. All right, so we have subtraction of two terms here. So the first thing I'm going to do is subtract the natural log of 0.88 from both sides. So I'm going to calculate this and then calculate this and subtract. So the natural log of 0.14, we have negative 1.966 minus the natural log of 0.88 is it's negative 0.1278. Again, carry all the digits on your calculator, and that's going to equal to, don't lose this negative sign, negative 2.8 times 10 to the negative 2 times the time. All right. So the negative 1.966 minus the negative 0.1278 get negative 1.8382 equal to negative 2.8 times 10 to the negative 2 times the time. So then I can divide both sides by the negative 2.8 times 10 to the negative 2. And I get the time is equal to 65.65 seconds. So about a minute.